Okay, so hello everybody. Welcome to my Go talk. My name is Pavlo Gulob. I'm working for Cybertec. They call me senior consultant slash developer. I prefer to think about myself that I'm a young developer. Yeah. About Cybertech, about my company. So we are PostgreSQL centric company. We are working with PostgreSQL and anything else. So if you want to be our client, you need to have Postgres. If you don't have one, we can run it for you, and then you can be our client. So probably some of you maybe have seen some of our free and not so free products. Just all of them are on the screen. Of course, we provide any kind of services for Postgres, support, consulting, performance testing, migration, etc. We currently have 6 offices, 6 branches. The main branch is in Europe, Austria. We are working on opening our office in India, but not yet. Meanwhile, if you want to have our services, you can contact our best partners, Open Source DB. We are working with them very closely. Thanks them for providing the support and help in helping you people. Another partner I want to mention is a Rediset. This is our technological partner. They provide a very cool data scaling and query caching solution. So it's easier to see on the demo on the site how it works than to explain in words. So just give it a try and see how you can make your queries lightning fast. Okay, so first of all, I want to ask you, how many of you are developers? Good. So I believe so. These are the old developers in this conference, right? So usually, Postgres conference is considered to be DBA conference. I'm not. I don't agree with this. I think that development is important part of the Postgres and our world. So, and how many of you already know Go or some basics? Cool. So I will try to dive deep then to explain what is Go and why we love it, right? So at the end of this talk, we will know what is Go, I mean the language. We will learn which IDs and tools are available on the market, what drivers we should use and which shouldn't, what useful extensions do we have now, how we approach testing, because we are dependent on the database, and some tricks about CI/CD. Have no idea what these letters mean. Continuous something, continuous something. Okay. So intro to Go, I will briefly go through it because you already know it. So why we love Go? Because it's simple, it provides native binaries. It allows you to write concurrent code easy without knowing much details about threads and processes and all other things. It has comprehensive tools and IDEs and editors. And what is most important from my point of view, it provides the Go builds cross-platform binaries without any external dependencies. So you can just build your code for any platform you need and you have it, right? So where Go is used nowadays, so as you can see, mostly in APIs, services, some libraries, frameworks, automation agents. Not very famous, not very used in desktops or GUIs. It's a pain in one place to write a GUI application in Go. But anyway, I like more this kind of survey in 2020 where the question was in what areas you use Go. So at that time you can see that databases was like half of all the answers. So I mean, half of developers use the database in their everyday work. Some top products written in Go out of my head, on top of my head, like Kubernetes, of course, like well-known, Prometheus, OpenShift, Grafana, etcd, which is like usually the part of Patroni deployment. If we are talking about Postgres-related products written in Go, then we should mention CockroachDB, which is not a Postgres fork, but it uses Postgres dialects to communicate. Terraform, why it's here, I don't know. PGWeb, all Postgres operators are written in Go because Kubernetes is written in Go. WolG, PGWatch monitoring solution, PGTimetable, and if you were present on my colleagues Ans Asma talk about Explain, there is a cool flame graph generator for Explain output. You should give it a try. Okay, so if you're interested, what is more in the Go? Yes, I'm a maintainer of PGWatch. Sorry, this is like the advertising. Yeah, so if you want to know more applications, like you can visit Awesome Go site, or there is a new trending page on GitHub, Trending Go. There you will find a lot of different cool applications. Just give it a try. Okay, so IDEs and tools. So December survey stated that we have two most used IDEs, VS Code and Golang IntelliJ from IntelliJ. We have like increased number of NeoVim users, but other than that, the situation is stable. So this is like situation 2 years before that. So VS Code was like significantly more popular, but nowadays there's no more like, I mean, every new IDE has a good support for Go. So if you're like anything else, you should try it. So my environment is VS Code with the standard plugin. So I use tparse library for good output of my tests. I use linters by Golang GCI. Copilot is part of my toolbox. I can live without it, but I mean, if we have it, let it be. Go Releaser, I use it to create the packages and binaries for releases. And of course, PostgreSQL, because we Postgres company. And the Docker, especially Docker Compose and dev containers and test containers are very helpful if you need to debug anything that depends on many other services, so you can easily like set it up, then erase and try again, right? So PostgreSQL drivers. I won't talk about ORM. I think that every developer should start with the plain libraries and start to learn how to work with database without ORMs. Why don't I like ORMs? Because I mean, people think that they will help, but they not. For example, if you know the application PhotoPrism, so they started to use ORM for their application. Now they wanted to switch to Postgres from MySQL, and the pull request is like 1,000 lines of code. So ORM doesn't provide you with ease of switching. So it's like not like that. And yeah, if you have SQL, why should you use ORMs? So first of all, if you start to learn Go and how to work with databases in Go, first thing you will learn is database SQL. Like this is like the idiomatic way of working with databases in Go. But database SQL itself is a set of interfaces. It's like a contract which you need to follow. That means you need an implementation. And for each database, you have one or more implementations. For a long time, the standard de facto was libpq. And many people think that libpq is kind of standard library, but it's not. The guy registered lib repository long ago. I mean, it's not a repository, it's a company, right? And the pq. So libpq is the only repository in the lib project, something like that. And so it is already in maintenance mode, like for several years. So only probably like old applications still use it. The new one is JAX-C PGX, which is default choice nowadays. And the thing is, both of them allows you to work with the database SQL. So I like the star history charts. They can let you feel how one project is like comparable to another in meanings of like the popularity. So as you can see, like in the middle of 2023, the PGX went high because the new major version released, and it was really cool. Okay, so what we should use nowadays, PGX or database SQL? Which approach is better? So if we are targeting only Postgres and we are starting our new project, PGX is a good way to go because it's like it's native implementation for Postgres without any compatibility issues with other databases. Otherwise, if we want to use database SQL interfaces, for example, if we are dependent on some other external libraries or ORMs, for example, we can still use PGX as our library, connection library, but we need to use stdlib, standard lib, for like a wrapper between the interfaces and the native implementation. Why should we use PGX nowadays? I mean, because it's written for native support of PostgreSQL, meaning it's from the start works with all built-in Postgres types. And every custom or user-defined type you will add later, you can add it to PGX as well, explaining how to use it, right? So it's automatically use statement preparations, caching. It can batch queries, like sending them several at once. Copy protocol is very essential if you are sending a large amount of data. Login tracing. The connection pooler is included in the box. Listen, notify, for example, it's nearly like impossible to implement listen, notify things in database SQL without knowing some dirty hacks. Well, a lot of things, and all of these unique features are not present in the database SQL. In the interfaces that are like intended to work with any database, MongoDB, MySQL, etc. So how Hello World look like? Can you see it? Or not good? The screen is not good. Okay, so I will read it. So if we want to use database SQL driver, we anyway import the standard library. So we import standard library from PGX, then we open the connection, but it's not, I mean, we open the pool of connections, by the way. SQL will always provide you with a pool of connections, meaning that if underlying driver decides that you need another connection, real connection, it will like start it, right? So if, for example, if you have several Go routines in parallel, and driver will say, okay, so I need like 10 more connections to work with these Go routines. Then we just query, put like our results into some variable, and we are done. So if we're talking about PGX, it looks pretty much the same. So it's idiomatic way, but with PGX we have like two options. We can go with one connection, or we can go with pool of connections. So if you use PGX Connect, that means you will create only one connection. And you shouldn't use it in like some parallel way. You need to be clear with this. So yeah, same, we can query some data, put it into some variable, and we're done. And if we want to use like a pool of connections with PGX, we have a special PGX pool implementation, which will return the pool just like for database SQL. all three codes are pretty much the same. If you wake up me in the middle of the night, I won't tell you the difference anyway. Okay, so useful extensions. I mean, one thing why people use ORMs is because it allows you easily to serialize, deserialize data from objects to objects, right? Well, it's easy to do with a lot of extensions there. So probably the most known is JMoron SQLX. It supports not only the Postgres, it supports like many more databases. So you can like serialize, deserialize data directly from database to database. For example, if we have some structure with, for example, country, city, and telephone code, and in our database the telephone code field is telcode, we can specify a special tag indicating which name to use, and then we just do query X, and we can scan into the structure directly without going row by row, field by field. It's really cool and very convenient. The same goes for maps. The same goes for slices. So if you have like a list of rows and you want to scan them into the slice of the objects, you just define your slice and you like put this slice into the select, and you're done. So at the end of the day, you will have like everything you need from the result set without checking all this and going through the rows. And if you decided to use PGX, you don't need anything. Why? Because it's written already with all this in mind. So everything you need for serialization, deserialization is already there. So there is collect rows functions and row to many like family of functions. So you can do row to structure. You can do row to pointers to structure. You can have your own functions if you know some hidden logic you need to implement. So this is very simple. Like you do query, then you call the function, and everything is saved to the either slice of structures or to the structure. Another thing I want to mention is SQLC. It's a cool thing. It allows you to generate type safe code from your queries. So if you have a list of queries you want to use in your application, like insert something, select something, create something, you can divide it. You can put it into the one file, and then with the SQLC, it will generate for each query this special method in Go, which you can then call without like worrying about some changes in underlying tables or data types or like that. And the cool thing is that these queries that you run, they're in text form, in SQL format, so you can put it into your version control system, and it becomes the part of your application. So instead of looking at the code where you need to change your query next time, you will have all the queries in the same file. You will change it, you will regenerate the Go code, and you're done. Now about testing. So we have like 3 big approaches to test. Of course, we can run a real Postgres server locally and run everything that we want, just like create a database, create schema, do test, erase everything, start from beginning, right? Another cool thing is test containers. They allow you to manipulate with the test instances from your Go code. So in your Go testing code, you just say, okay, I want a test server Postgres 14 with that, and that. It will create it. It will provide you with a connection string. You do your magic testing, bumps, everything at the end. It's done and it's deleted. And the best thing, since Go can run tests in parallel, you can specify the maximum amount of instances you can create with test containers. So, like for a big project, you can do like hundreds of test containers in parallel doing their own tests without interrupting each other. And we all know how it's like not convenient when one test result can improve another test if you don't clear it before, right, and recreate the schema. Another way without real server is the mocking libraries, like GoSQL mock for database SQL and PGX mock implemented by me, for PGX. So the thing is that instead of calling or speaking to the real server, we are describing our expectations about the behavior of our function, and we define the reaction of server on our expectations. I will show you in a minute. But if we want to go like really low, so we can mock the wire protocol of PostgreSQL. So there are like libraries to emulate the Postgres on the other side. The funny one is CockroachDB copies. So when you first run it, it records the session. During the second run, it just repeats the recorded sessions and answers what's recorded previously. So it's like, okay, so can you see it? So let's see example how can we mock the test. So for example, we have a record stats function. So first of all, we need to pass the interface to our function. Otherwise, we cannot mock anything, because interface allows us to replace the real connection with our own implementation, so our function doesn't know, right? So in this function, we want to start a transaction. Then we have a deferred function, which will be called at the end of the function. So depending on the state of error, if we have no errors, then just commit. If there is some problem, then rollback. And during the execution, we want to update one table, and we want to insert another row. Nothing extra complicated. Now, I prefer to start with the successful tests. I'm a very positive man, so I like this. So first of all, you can see that we create the mock, so PG mock new pool. Then we want to describe our expectations. I know how my function works, I just said, right? So I expect that it will start with the transaction start, right? Then I expect that it should try to update. Then I expect it should try to insert. And then I expect that everything is okay, it should commit. These are my expectations. Now I need to explain to PGX mocks how to react on my expectations. So I tell, when you see update, pretend that everything okay, and update, like return one row. And if you see insert, pretend that you are waiting for arguments 3 and 2, 2 and 3, and then pretend that everything okay, you insert it. And then just I start my code, and if there are some errors, then something bad happened, we need to fix it. And another thing is, I want to be sure that all expectations were met. For example, I want to be sure that my insert done. I'm not like interested in knowing there are no errors. I'm interested to know that everything went as I expected, right? Now let's see how can we test the failing case, right? Because this is like the problem, to test failings, to test errors, how to simulate those errors. So here, I will say, when you see, for example, yes, I expect begin, I expect update, I expect insert, but now I say, when you will see insert, pretend that something bad happens. And instead, return the error. And then I expect it should be rollback because something bad happened. Then again, I'm running my record stats function, and I see that now I'm expecting the error because I'm testing the bad case, the fail case. Okay, if there is error, it's good. And now, again, I want to be sure that all expectations were met and we are fine. It's okay, easy, cool. Now, then testing. I run a lot of them, and I love to have the coverage 99 and more, the green one. So to see the output of go test command in a fancy table, I use a tparse command. So it will just show you the status of the test, the coverage, the number of passes, and other funny cool things. It's it's not mandatory. I just love the output, and that's why I have it. What the coolest thing is in Go tooling is Go automatically may produce the coverage in HTML output, and you can see it in your, so for example, I made some tests here on a real project, and now when I run Go tool coverage, it should open the my web browser, and here in dropdown I will see all files that are covered by tests, and I can see the coverage. So for example, if I go here, so 87%, and with red I see lines that are not covered. Yeah, none of them are possible to cover easily due to some async execution like that. Just showed you. Okay, continuous integration, continuous deployment, right? So we are using GitHub, but the same applies for GitLab and any other, do we have any other providers of version yes. Yeah, version control system. Yes, exactly. So usually in every my project I have at least 5 GitHub workloads. First two, Dependabot and CodeQL, are the part of GitHub environment. The GitLab names them differently. So the first one is responsible to continuously monitor updated packages and create new pull requests with updates. And CodeQL should analyze packages, external packages, and my code and anything else for vulnerabilities and provide some warnings if we have some, right? The main one is build and test action. It fires on every pull request, on every commit, on every action that somehow tries to change the source code, right? Then we have a special release action, which will monitor the new either release or tag, and will produce the binaries, packages, everything, and publish them on GitHub. And the other one is a Docker action, which will automatically build Docker images and push them to the registry. So let me show you how they look like in real project. So, for example, GitHub is very cool platform that allows you to do testing that sometimes you cannot do locally. For example, for one of our project, this PG timetable, we have tests for 3 different platforms. One is Windows, another one is macOS, and the Linux is the last one. And for every of these platforms, we want to use native Postgres installations. to be sure that we are working smoothly on every platform, right? So during the each job, we can install the Postgres on that platform. We can check if this running. We can create our test databases, prepare something, then we can test it. And at the end of the day, if so we can run also the linters test, and we can run the coverage action. So you will have a history of the running build actions and you will see how the coverage of your code is changing, right? This is build one. The release one is pretty simple. So we are using the Go releaser action, and it will produce everything you need automatically. The everything you need you define in your YAML project. You specify the operating system you want, you specify the targets you want, you specify the name of the binaries, you specify either you want archives or deb packages. It's very extremely customizable, so it's up to you. And the last one is a Docker one. So for this project, I use only the AMD 64 platform, but for another project we can produce multi-platform images really easy on the GitHub without using any external services. So what we do is we just use the predefined Docker action, and it will just publish everything we want to our Docker registry. On the other hand, if you don't want to use some actions, you can just execute Docker commands in the GitHub workflow, and it will work in the same way without any problems. Okay, so that we covered. Takeaways. So, Go is a popular language, and it's fast, it's easy, it's well scaled. We know that at least half of developers work with database in one way or another. There are plenty of editors, IDEs that you can use, even online is pretty good. If you want to work with Kubernetes, the Go is probably the way to go because the whole system is written in Go. It's really flexible, so if you start your project, you are free to choose which one way to use the database SQL, the idiomatic way or the native Postgres PGX interface. There are a lot of tools and integrations, including testings and testing containers and development environments and so on, just name it. And the main thing is Go is backward compatible absolutely. So the API of the Go will grow, but it will never break the version 1 agreement, right? So, for example, even now when we have 1.23, 1.24, some of the native libraries of the standard libraries were replaced, but you can control which version of the standard library you want to use. So if you just specify, I don't know, random, right? So crypto, it will use the default one. But if you know that you are on the new version and you exactly want to use the new one, you can add /v2, and your compiler will use the last one. So if you have any questions, it's right about time.
Do you have any migrations tools with the Go? Recommend any migrations tools? We have seen the database driver, but what about the migration part?
So the question is, are there any migration tools to migrate applications from other database?
No, schema migration, alter statements or PDF.
Aha, okay, good. That's a good question. So we are speaking about version control, schema control, right? So let me show you how I did it. It's not like the universal way. So there are some schema version control tools like Stitch or Sketch, yeah, yeah, Screech, yes, but they are external. On the other hand, I like to have everything under my control. That's why. Let me open another project. I don't remember. Migration, yes, this is one. Yes, thank you. So the idea is to have like migration implemented in your own code. This way you control absolutely. So your application is in charge, is in control of what schema your database will have. So the idea is I start my application, it checks the version of the schema. If the version of the schema is outdated, my application says, okay, run me again, but now with the upgrade flag, if you know what you're doing, right? If not, just use the previous version of binary. So the thing is, there are like several functions, like one of those check neat. Can you see it? Maybe should I? It's better. So one of them is like check neat migrate DB. Do I need to migrate? And another one is migrate DB. But the thing is how we store the migrations, right? So migrations is the function which in fact return the slice of migration. The migration has the name, unique name, and migration has some functionality, like what to do, right? So in order to keep the Go file shorter, what I usually do is I have like a special SQL folder with set of migrations here. And what I do, I just call the every migrations from this file. For example, here I added some new column, or here we change how the function behaves, or here, no, here, no, here. Here, for example, we added like more like functions and how they do like things, right? So this is one way to go. Another way to go is when the database is first. So when you first upgrade the schema on your database using Sketch, or I don't remember the name of another one, Liquibase, yeah, or Flyway. Then we have a Go specific one, Goose, yeah, this one, yeah. So either this way. So first you control the schema and then you like redeploy your application. Both ways are valid. I like to be in control because I'm a developer. I like to control the database. I don't like when DBA controlled me. I like the opposite. So the only thing is like your application need to have like the privilege to apply these new settings. So probably during your normal run, you will run on the one row, and if you need to upgrade your application, you probably will write with the elevated permissions. So that's the difference. Otherwise, yeah.
So you are coding on the migration yourself, like you are not using third-party tools. I mean,
So all of my migrations are stored here in SQL files. But if the migration is complicated enough to use SQL, I can write my own function here. For example, if we want to add a new migration, right? So I will just, let's try to uncomment it. So I will say that this is, I don't know, This is PGConf India update, and then I will execute here some pretty complex function, and it will do the job, like maybe checking something, maybe downloading something. I don't know. It's up to you. So if the plain SQL is not enough, you're always have the ability to use Go as a migration tool.
So if the prepared statements are on, I think when you do a migration, you'll get an error, right? The plan has changed or something. The plan is not relevant anymore because plan is a session level, the parameterized plan. So did you see that kind of error before when you run migration? The existing plan would have already have a parameterized plan, right, in the session.
You mean cache plans like that? Well, it's not my problem. It's a problem of DBA. Yeah, I mean, if you do migration, if you change the behavior of your program and the whole system, yeah, of course something might be broken, but it's not an error, right? It's just like a slowdown. So the Postgres will need some more time to build a new cache plans, right?
I don't know if it gets automatically invalidated.
No, so if we are speaking about the schema, right? So the database schema. So we are focusing here on the right tables, right columns, right things. So we are not speaking here about the runtime. So I need to be sure that every table we use, every object, every function we use, it's in the shape that I need now. But yeah, I cannot guarantee that during runtime we will not have any like performance issues.
Also with PG bouncer, with Postgres we generally use PG bouncer pooler.
Yes, we can use it.
This PGX pool as well. Did you face any issues using pool PGX pool plus external pooler together?
Well, PG Bouncer has its issues with the PGX because they are both very smart, and the PGX started trying to prepare and cache statements, and PG Bouncer tried to prepare and cache statements. So if you want to run PG Bouncer in statement mode, that's probably not going to work. But in session mode, there are no any problems. Yeah, it's time. Thank you very much for your time.